Hello and welcome back to another Physical Sciences 3 lecture. Today we're looking at mechanical power. So mechanical power, we will look at another type of power called electrical power, but we're just focusing on mechanical power. And mechanical power is defined as work over time. And in the last lecture we saw that work is a form of energy, or it's a change in energy, really. So I just want to emphasize that. I always think of work just as energy. So when I say power equals work over time, I think of energy over time. And it's the rate that energy is essentially dissipated or used by a certain device, usually. So like you often hear cars will have power, and now they're in kilowatts, okay? So a watt, 1 watt, is 1 joule per second. So it's one piece of energy, if you like, per second. 1 unit of energy per second. And so power is simply how much energy can we use in a certain amount of time. So it's key, the time thing is key. Okay, so change in energy over time. That's what this is here. So we had power is equal to work over time. And if we just substitute work is equal to change in energy, maybe I'm labouring the point now, but power is then change in energy over time. Right. So let's do some examples. So calculate the power required to do 2.4 kilojoules of work in 2 minutes. Okay, so the key thing here is that energy is in joules. So that's going to be 2,400 joules. And time is always in seconds. So power equals work over time, which is equal to 2,400. 2.4, and just remember 2.4 times 10 to the 3 is equal to 2,400. Okay, so that's what that little conversion is. And 2 minutes, so we have to type that 2.0 times 60. And then we can put that into our calculator. Where's my calculator? There it is. Let my calculator load up. There we go. Go to main, and we have got 2,400 divided by 2 times 60. I guess you could have just put in 120 if you want to do the maths in your head. So it's 20 watt. And it is 20 watts. I was saying 20 watts. 20 watts, and we write that as 20 W. Okay, 20 watts of power is used in 2 minutes. Okay, if we want to lift a 65 kilogram mass 6 meters in 9.2 seconds. Okay, so again, so we can start off with power is equal to work over time. But what's work equal to? I'm going to do that over here. Work is equal to force times distance. And the force that we're overcoming is gravity. So force is going to be 65 times by 9.81. And then it's 6 meters times by 6.0. Okay, so our work, I could have put it over here, but whatever. It's not a lot of room. Let's have a look. So 65 times by 9.81 times by 6.0. Okay, so we can say that that is 3,825.9 joules. Okay, I'm keeping that with lots of decimals because I want to use it in this calculation over here. 3,825.9 divided by 9.2 equals, just chuck that into the calculator, should just be able to go answer divided by 9.2 now, and it's 415.9 or 0.8, oh no, 0.9, so let's just go up to 416. We're going to go to 416 watts. And that's the 3 significant figures. We'd probably, because all these are in 2 significant figures, we might just want to say it's 420 watts to 2 significant figures. So either way, in our course, we would have been fine with 3 significant figures, but technically 2 is right. Okay, so accelerate a 500 kilogram car from rest to 72 kilometers an hour in 6 seconds. Okay, so there's a bit more involved in this one. So if we're saying that power equals work over time again, so we can say that. This time we want to work out what the force is, but we're going to say, well, work is equal to force times distance. So, but to work out the force, it's equal to mass times acceleration. Okay, accelerate car from rest to, oh yeah, we've got the time, that's fine. So we don't have distance. So work is equal to force, which is equal to ma times s. Okay, now a, if we look at v squared equals u squared plus 2as, so it's quite a fair bit of mass we have to do here. We then have to, so that's why I've got so much space. So I'm going to go along this side. So work is equal to v squared equals u squared plus 2as, and also our u is equal to 72 kilometers an hour. U equals 72 divided by 3.6. I'm not really doing this in a very logical way. It's a bit all over the place, but that's alright. 72 divided by 3.6 is equal to 20. Good. So 20 meters a second. Okay, so let's just do that. Well, actually, I'll do it somewhere else. So just remembering our SUVAT. So SUVAT, to work it all out. S we don't know. U is 20 meters per second. V is equal to 0 meters per second. A, we're trying to work that out. And T is equal to 6.0. Okay. Now I am going to use, still going to have this equation here, and the reason is because I want to cancel out the s's up here. So this is actually quite a challenging problem. So let's put in what we don't know, or what we do know. So v is equal to 0, but that's equal to 20 squared plus 2 times as. Okay, so we end up getting 20 squared is 400. So we're going to end up with negative 400 is equal to 2as. And then I'm going to rearrange for a, so we divide by 2, so it's going to be negative, so a is going to be equal to negative 200 over s. Okay, and now I'm going to sub it back up into here, so so therefore work is equal to mass times by negative 200 over s times by s. And see how those s's cancel? Okay, so we know that we've got a 500 kilogram car, so therefore work is equal to 500 times by negative 200. Okay, and we end up getting 200 times that is going to be negative 10,000. Okay, negative 10,000 joules. But what is negative 10,000? The reason it became a negative is because acceleration, because it's going from it's going from 72 kilometers an hour to rest. So it's in acceleration is in negative direction. But just remember that work does not have a direction, or energy is scalar. So it's always positive. Plus. We'll say that. Okay, but it came out as negative here just because it's working in the opposite direction. Alright, so we've got work is equal to 10,000 joules. So therefore, our power is equal to 10,000 divided by 6.0. Okay, so the watts that we use up divided by 6.0. Okay, so it's equal to, we're going to go to three significant figures, I think. So 1,670 watts. Alright, okay, and that was quite a convoluted way of getting to it. If there's an easier way, please email me. That's a bit of a challenge for you. There might be an easier way to do it than that. but that's just the way I did it first up. Okay, we'll do some more examples later on.